Now in this video, we're going to answer the following question. Find the area of the finite region between the curve and the x-axis, where the curve has the equation y equal to x multiplied by x minus 4 squared. If you find this video helpful, please consider leaving a like, a comment, sharing this video, and subscribing to our channel for more content like this. Integration is the mathematical process of finding the accumulated total of something that changes. Definite integration is a way to find the signed area between the graph of a function and the x-axis over a specific interval. It is the net area between this curve and the horizontal axis from a specific start point on the x-axis to a specific end point. Answering this question is a 5-step process. First, we need to identify the x-coordinate for the points of intersection between the curve and the x-axis. Then, using those values as limits, we need to integrate the expression we've been given in terms of x, substituting the limits, then subtracting to find the area. To begin, we need to find the coordinates of the point of intersection between the curve and the x-axis. For points on the x-axis, y has the value 0. Setting y to the value 0 gives us an equation that we can solve. 0 equal to x multiplied by x minus 4 squared. There are two solutions to this quadratic equation. One, when x is equal to 0, and a second when x minus 4 squared is also equal to 0. By taking the square root of each side, we get x minus 4 equal to 0. And by adding 4 to both sides, we get a value of x equal to 4. So the two values of x where the curve intersects the x-axis are 0 and 4, giving us two limits between which we can integrate the function. X multiplied by x minus 4 squared with respect to x between the limits 4 and 0. Expanding the squared bracket makes integrating the function easier. And x minus 4 squared is x squared minus 8x plus 16. So we need to integrate x multiplied by x squared minus 8x plus 16. With respect to x, between the limits 4 and 0. We can also multiply x by every term inside the bracket, giving us the integral of x cubed minus 8x squared plus 16x with respect to x, between the limits 4 and 0. The power rule of integration tells us to increase the exponent by 1 and divide by the new exponent. Integrating the expression therefore gives us 1/4 of x to the power of 4 minus 1/3 of 8x cubed plus 1/2 of 16x squared, between the limits of 4 and 0. Substituting 4, then 0, and subtracting gives us 1/4 of 4 to the power of 4 minus 1/3 of 8 multiplied by 4 cubed plus 8 multiplied by 4 squared minus 0. Because substituting 0 for x in each term is 0. Simplifying this, we get 64 minus 1/3 of 512 plus 128, which simplifies to give us 21 and 1/3. For more explanation and examples of definite integration like this, search our channel for definite integration. As an extension to this question, what if the graph went below the x-axis? The integral would give a negative number. How would we state the total area in that case? So the area of the finite region between the curve and the x-axis, and the answer to this question is 21 and 1/3. Please follow us on Instagram, TikTok, and Threads for daily maths content.